SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, new evidence that Martian lakes were around far longer than previously thought, the Ceres pyramid mystery finally solved, and China launches its new space station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
There's new evidence from Mars that lakes and snowmelt-fed streams on the red planet's surface may have formed as recently as 2 to 3 billion years ago, much later than previously thought possible. The new findings, reported in the journal Geophysical Research, show that recently discovered lakes and streams appeared on the red planet's northern Arabia Terra region roughly a billion years after a well-documented earlier era of wet, warm conditions on ancient Mars. The results provide new insights into the climate history of the red planet and suggest that surface conditions at this later time may also have been suitable for microbial life. Up to about 3.5 billion years ago, Mars was a warm, wet world with rivers and oceans and a thick atmosphere. However, all that changed when the tiny planet's molten core began to cool and solidify, shutting down the Martian magnetic field which, like the Earth's, protected the planet's atmosphere from being blown away by the sun's solar wind. One of the new study's authors, Sharon Wilson, from the Smithsonian Institute in Washington, D.C. and the University of Virginia, says the findings are based on the discovery of valleys that carried water into lake basins. Wilson and colleagues identified several lake basins which filled and overflowed, indicating there was a considerable amount of water on the landscape during this time. The authors found evidence for these features by analysing images from the Context camera and the High-Resolution Imaging Science Experiment camera, both fitted to NASA's Mars Reconnaissance Orbiter spacecraft. They then supplemented that data with additional observations from NASA's Mars Global Surveyor spacecraft and the European Space Agency's Mars Express probe. One of the lakes in the region surveyed is estimated to have held some 188 cubic kilometres of water, fed by an inlet valley on its southern edge and then overflowing along its northern margin, carrying the water further downstream into a very large water-filled basin nicknamed Heart Lake. The chain of lakes and valleys forming the Heart Lake Valley system extends some 150 kilometres. Wilson and colleagues have calculated that Heart Lake probably held something like 2,790 cubic kilometres of water. That's more water than Lake Ontario in North America's Great Lakes. The authors carefully mapped the extent of stream flow in the fresh shallow valleys, as well as their associated former lakes, finding that the runoff which formed the valleys may well have been seasonal. To bracket the time period when the shallow valleys in Arabia Terra formed, scientists started with age estimates for 22 impact craters in the area. They assessed whether or not the valleys were carved into the debris ejected from the impact craters, using that as an indicator of whether these valleys were older or younger than the craters. They concluded that this fairly wet period on Mars likely occurred between 2 and 3 billion years ago. That's long after it was generally thought that most of Mars's original atmosphere had been lost and most of the red planet's remaining water had frozen. The characteristics of these valleys support the interpretation that the climate was cold. The rate at which water flowed through these valleys is consistent with runoff from melting snow. That means these were not rushing rivers. They have simple drainage patterns and didn't form deep or complex systems like the ancient valley networks from early Mars. Wilson and colleagues found similar valleys at other locations around the red planet, all between about 35 and 42 degrees latitude, both north and south of the equator. The similar appearance and widespread nature of these fresh shallow valleys on Mars suggests they formed on a global scale rather than simply a local or regional level. Mars Reconnaissance Orbiter Project scientist Rich Zurich from NASA's Jet Propulsion Laboratory in Pasadena, California, says one of the key goals of Mars exploration is to understand where and when water was present in sufficient volume to alter the Martian surface and perhaps even provide habitable environments. The findings are likely to prompt more studies to try and understand how conditions warmed enough on the frozen planet to allow an interval with flowing water. One possibility is an extreme change in the planet's tilt, resulting in more direct illumination of polar ice. NASA's missions to Mars are preparing the groundwork for eventual human missions to the red planet sometime during the 2030s. A mysterious pyramid structure discovered by NASA's Dawn spacecraft on the surface of the asteroid Ceres is now believed to be a recently active cryovolcano, powered by muddy salt water rather than molten lava. The findings, reported in the journal Science, indicate the volcano, which has been named Ahuna Mons, has only a few impact craters on its flanks, indicating it formed fairly recently, within the last couple of 100 million years. Rising to a height of almost 3,963 metres, with a base over 18 kilometres wide, Ahuna Mons would be impressive for a volcano on Earth. Instead, it sits on the relatively flat surface of Ceres, a tiny frozen world less than 1,000 kilometres wide, orbiting the Sun in the main asteroid belt between Mars and Jupiter. In fact, the pyramid-shaped dome is considered the only true mountain on Ceres. As there's no evidence of tectonic movements, scientists think it was most likely formed from repeated eruptions of freezing salty water. In the outer solar system a long way from the Sun, where temperatures are far colder than on Earth, water exists primarily as a solid, often forming bedrock. Cryovolcanism is a form of low-temperature volcanic activity, where molten ice water, usually mixed with salts or ammonia, replaces the molten silicate rock which erupts as lava from volcanoes on Earth. The implications of Ahuna Mons being volcanic in origin are enormous. It confirms that although Ceres' surface temperature averages just minus 40 degrees Celsius, its interior has somehow kept warm enough for liquid water or brines to exist for a relatively long period, allowing volcanic activity at the surface in recent geological time. Ahuna Mons isn't the only place where cryovolcanism happens on Ceres. In fact, Dawn's instruments have spotted numerous features that point to cryovolcanic activity, which is resurfacing wide areas of the dwarf planet, rather than building tall structures. For example, there are numerous craters which have floors that appear to be far flatter than what one would expect from a meteorite impact. And that leads to the possibility that these impact crater floors may well have been flooded from below. In addition, these flat-floored craters often show cracks, suggesting that icy magma has pushed them upwards, then subsided. The famous Ahuna crater has several bright spots on its floor. The central spot contains what looks like a cryovolcanic dome, rich in sodium carbonates. Other bright spots occur over fractures, suggesting venting of water vapour mixed with bright salts. And as the vapour boils away, it leaves the bright salts and carbonate minerals behind. Although volcanic-related features appear across the surface of Ceres, for scientists, perhaps the most interesting aspect of all these features is what they say about the interior of this dwarf planet. Dawn's observations suggest that Ceres has an outer shell that's not purely ice or rock, but rather a mixture of both. Scientists have also discovered that there are many large impact craters which are missing, presumably erased by internal heat. However, there are lots of smaller craters which are well preserved. Now, this shows Ceres' crust must have a variable composition. It's weak at large scales, but fairly strong on smaller scales. Ceres appears differentiated internally, with a core and a complex crust made of 30 to 40% water ice mixed with silicate rock and salts. And it's thought there are probably pockets of liquid salt water brine still existing within its interior. Ceres is the second asteroid belt world visited by the Dawn mission, which was launched back in 2007. The spacecraft spent 2 years orbiting another asteroid, Vesta, during 2011 and 2012. Dawn achieved orbit insertion around Ceres in March 2015. The probe carries an array of cameras, spectrometers and gamma-ray and neutron detectors designed to image, map and measure the shape and surface materials of Ceres, collecting information to help scientists understand the history of these small worlds and what they can tell us about the solar system's birth. NASA plans for Dawn to continue orbiting Ceres and collecting data for another year or so. The dwarf planet is slowly moving towards its closest approach to the Sun, called perihelion. That will occur in April 2018. Scientists are hoping the growing solar warmth will produce some detectable changes in Ceres' surface, maybe even triggering volcanic activity such as active venting. We'll keep you informed. September equinox will take place at 21 minutes after midnight on the morning of Friday, September the 23rd, Australian Eastern Standard Time. That's 10:21 a.m. US Eastern Daylight Time and 14:21 Greenwich Mean Time on Thursday, September 22nd. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise directly due east and set directly due west to someone standing on the equator. Of course, it means almost an equal 12 hours of darkness and 12 of light. In fact, the word equinox is derived from the Latin meaning equus or equal and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of about 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. That axial tilt is pointed to the same direction of the sky, regardless of Earth's orbital position around the Sun. On any other day of the year, either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, around March 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those listening in the northern hemisphere, of course, it means the start of autumn or fall, while for us south of the equator, it means a move into spring. However, there is a complication to all this called precession. Precession causes the Earth's spin axis to wobble ever so slightly, like the axle of a spinning top. Mind you, the rate of precession is only about half a degree per century, so people don't notice it in human timescales. Because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season, for example the southern hemisphere summer, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, the orbit itself is also subjected to small changes called perturbations. Earth's orbit is an ellipse, and there's a slow change in its orientation which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. The two effects work together to shift the seasons with respect to perihelion. Because we use a calendar that's aligned to the occurrence of the seasons, the date of perihelion gradually regresses through the complete 21,000-year cycle. And there's another complication. For some weird reason, Australia starts its seasons on the first day of the month rather than on the solstices and equinoxes. So that means in Australia, spring doesn't begin on the morning of Friday, September the 23rd, but in fact began back on September the 1st. It's all very confusing. China has successfully launched a new space station. The Tiangong 2 was blasted into orbit aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center in China's Gobi Desert.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1，点火。12秒，428毫秒，70，20。04分，金山 USB 雷达跟踪正常，遥测信号正常。
The 10.4 metre long, 3.35 metre diameter module has a mass of 8.6 tonnes and is designed to accommodate 2 crew members at a time on 30-day missions. Beijing plans to send 2 taikonauts aboard the Shenzhou 11 capsule in November for the first mission aboard the orbiting outpost. Tiangong 2 will be used to conduct 14 experiments, including a joint Chinese-European project to monitor gamma-ray bursts from exploding stars and merging black holes. In April 2017, Beijing will launch a cargo ship loaded with supplies and fuel to the space station. It'll be China's first space cargo mission. Tiangong 2 was originally built as a backup to China's earlier Tiangong 1 space lab, which was launched in 2011 and provided Beijing with its first in-orbit rendezvous with another spacecraft. Contact with the Tiangong 1 was lost earlier this year. Its orbit is now starting to decay, and at its present rate, Tiangong 1 is expected to undergo an uncontrolled fiery atmospheric re-entry sometime next year. As for Tiangong 2, it's expected to test new technologies to be used on the development of a much larger Chinese space station, slated for launch sometime during the early 2020s. Ariane Space has successfully launched a Vega rocket carrying 5 Earth observation satellites into orbit. The three-stage solid-fueled rocket blasted into the black late-night skies above the European Space Agency's Kourou spaceport in French Guiana, carrying PeruSat-1 and 4 small SkySat satellites for Google.
Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80, décollage. Propulsion nominale. Pilotage calme, trajectoire nominale.
As the DDO says everything is normal on board, Vega rise like an arrow surprisingly fast if you're used to watching Ariane 5 liftoff. DDO continues to say all is working perfectly. Those of you familiar with the Ariane flights know that the heavier launcher rises much more slowly, weighs 6 times what Vega does, carries 4 times as much propellant. Vega lifting off perfectly. French Guiana beginning her 7th mission, weighing at liftoff 138 tons. The first stage is burning now. It weighs 97 tons. 88 tons of that are fuel. Most of any launcher's weight is propellant. The first stage burns its single engine for about 2 minutes before being jettisoned. The first stage is produced in Colleferro near Rome, then delivered to the French Guiana plant here where it's loaded with fuel, then transferred to the booster integration building.
Arianespace mission VV07 was both the 7th launch for Arianespace this year and the 7th launch since the introduction in 2012 of the European Space Agency's 30-metre-tall lightweight Vega rocket. The Vega launch system is designed to lift light payloads into orbit. It complements the larger Roscosmos-Soyuz rocket, which carries medium payloads into space, and of course the Ariane 5, which is the agency's heavy-lift launcher. The 4 110kg Space Systems Laurel-built Google aerial imaging platforms SkySat 4, 5, 6 and 7 were deployed 40 minutes after launch at an altitude of 500 kilometres. The dorm room refrigerator-sized mini-satellites provide resolutions down to 90 centimetres and will be used to help update features such as Google Earth and Google Maps. The 4 spacecraft have been nicknamed R2-D2, Luke, C-3PO and Leia after the Star Wars characters. 6 more SkySats are slated for launch early next year aboard an Orbital Sciences Minotaur C rocket from the Vandenberg Air Force Base in California. Just under 2 hours after the SkySats deployment, at an altitude of 675 kilometres, Vega deployed the 430kg Airbus-built PeruSat-1 reconnaissance satellite for the Peruvian government. PeruSat-1 is equipped with an optical imaging system providing resolutions down to 70 centimetres. The spacecraft, which carries enough fuel for a 10-year lifespan, will be used to monitor drug trafficking and assist authorities with urban planning, agriculture and natural disasters. The Perth Observatory is celebrating its 120th birthday on Saturday. The observatory was the brainchild of Sir John Forrest, who wanted to build a telescope for the isolated British colony of Western Australia back in the early 1890s, but initially couldn't raise the much-needed financial capital. Fortunes changed for the fledgling colony, quite literally, with the discovery of gold on the outback Kalgoorlie goldfields east of Perth. With money from the gold rush, the good people of Western Australia were finally able to build an observatory in 1896 at Mount Eliza. The observatory was designed to provide accurate time measurements for navigation, as well as weather observations, sky mapping and seismic data readings. The observatory got its first big telescope in 1897, when the colony's first government astronomer, Sir William Ernest Cooke, travelled to England to collect the telescope and help set it up to map the southern skies. Cooke's first task was to determine the exact latitude and longitude of the Perth colony. He was therefore able to calculate the exact time of day with far greater accuracy than previously possible. Before Cooke's work, clocks would vary by up to half an hour. In a 1920 expedition, scientists from the observatory travelled to the remote outback sighting of Deakin to determine the fixed position on the ground of the Western Australian and South Australian border. In 1921, the team travelled to Wyndham in the Kimberley region in the state's far north, where, using the relatively new technology of radio, they travelled inland to Rosewood Station near Argyle Downs, close to the 129th meridian east longitude, to fix the position of Western Australia's border with the Northern Territory. The original Mount Eliza facility was moved to a new observatory at Bickley in the Darling Ranges 24 kilometres east of Perth in 1965. In 1967, the Meridian Circle telescope was installed at the observatory as part of an expedition from the Hamburg Observatory in Germany to develop a larger, more accurate meridian catalogue of the Southern Hemisphere skies. That chart became known as the Perth 70 Meridian Catalogue. Perth Observatory's Matthew Woods says the facility has played an important role throughout the state's history.
It started off in the earlier 1890s. Our first Premier, Sir John Forrest, wanted to have some nice public works buildings because we'd got a lot of money from the goldfield rushes. And so a lot of infrastructure was built into Perth, and one of them was Perth Observatory. Its first job was to actually map the sky for the southern skies because there hadn't been a lot of mapping of the stars in our skies, also to provide accurate weather mapping and also seismic readings for the settlement as well.
And was it also used to help with navigation, things like that? That's one of the reasons the Sydney Observatory got set up.
Yeah, Western Australia has a long, sordid history of Dutch ships colliding with our coast, so providing accurate time for the colony, and especially for Fremantle Port, was very important. We provided time up until the 50s and 60s to the tram service, the train service, the buses, and all the government clocks. So yeah, we were very important in the early stages of the state.
You're at your Bickley site now. That's not where you started.
No, they actually wanted to put it out in the observatory when it first started in Kings Park. And they got the South Australian government astronomer to come out and give them advice. And he actually advised the Mount Eliza hill in West Perth. It was a lot higher. It got away from any of the light pollution, even though at that time we were only just getting electricity. For future progress, it would stop the light pollution effects. And in the 50s, and the light pollution started getting a problem. And in the early 60s, the Western Australian government started up the Stephenson-Hepburn report into just basically planning the actual Perth metropolitan area. And one of the suggestion for the site for the Perth Observatory was actually where they were going to put together all the government buildings because we were so close to Government House. So that meant we had to move, and they decided to move us up to the Perth Hills because we were well away from the light from Perth and we'd get some really good viewing. So yeah.
And so what sort of work do you guys do now?
At the moment, official research finished in 2013. We were actually the longest government-run observatory. We got that record in Australia when Sydney Observatory finished up official research in 1982. So at the moment, the volunteer group, which was started back in 96 to help the actual astronomers do the night tours, we signed a one-year agreement last year with the government to run the observatory for them, and we've just signed this July a 10-year agreement. So we're continuing doing the public outreach of the night tours, the day tours for the schools as well. There's a future plan to actually try and get some more official research. We've got an internet telescope which people are using to do their own research.
And tell us about the facilities there.
Yeah, we have the main feature for the observatory is the Lowell Dome. Back in the early 60s, the Lowell Observatory in Flagstaff, Arizona actually contacted us and said, hey, we've got a telescope from NASA. Would you like to be part of the International Planetary Patrol Program? And we said yes. Basically, our job was to, with about 7 other telescopes, was to have 24-hour access to Jupiter, Saturn, Venus, and Mercury. So we built the dome on top of stilts, so it's about 15 feet in the sky to get away from the scintillation. So that's the big landmark. We have the astrographic telescope, which was the very first telescope for Perth Observatory. Still, we use it for educational purposes now. And we've got a whole public viewing area telescope. We've just, at the open day on the 24th, we're going to open up the new 30-inch telescope dome. So we'll officially have, I believe, the biggest publicly available viewing telescope in Australia.
Tell us a little bit about what else is happening on the open day.
September is a big month for us. The 120th birthday on the 29th. The 26th is the jubilee of the actual moving up to Bickley, and it's the 20-year anniversary for the Perth Observatory. So this coming Saturday on the 24th, we're going to have an open day. You'll be able to have a tour of the area for free. There's free admission. We've got solar viewing as well, so you can safely look at the sun through telescope. We've also got astronomy talks as well about the history of the Perth Observatory, the Whyalla expedition which Perth Observatory was part of that helped prove Einstein's theory of relativity.
General relativity, was it?
Yeah, many groups that all went up at the same time. So there was Canadians, there were US, people from England, there was people from Perth Observatory in Western Australia, and they all went up to 80 Mile Beach up in North Australia, and there was absolutely no infrastructure there. So they had to get the Navy to help them get up to the beach, and with some of the Aboriginal tribes up there, they transported all the gear, all the telescopes up to the beach and set up the mounts and everything like that. They had a solar eclipse, and they basically were looking for the light bending around the sun, so they're able to take those measurements. After failed attempts previously, and also because of the Great War, there was a period of time where no one was looking at these solar eclipses to prove Einstein right. So eventually we were able to prove that they were right.
This was a really important historical event, wasn't it? Because this proved that Einstein's general theory of relativity was correct, that mass really does cause light to bend.
Yeah, one of the volunteers is going to be giving the talk, and I've had a sneak peek of it, and it looks like it's going to be a really good talk.
That's Matthew Woods from the Perth Observatory. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine. This month, looking at whether the next generation of supercomputers will be able to handle the mega streams of data expected from the next generation of giant telescopes like the Square Kilometre Array.